A Magis Day, everyone! Please allow us to present 5 questions that are answered using Newton's law in physics.
Each question is completed by the learners who will be reporting them.
With that, let us proceed to the
In
presentation.
the first problem, we will find the net work done on the package, which is solved using the formula work total is equal to work done by friction plus work done by gravity plus work done by normal force. The given values 12 kilogram mass of the package, 2.00 meter for x, 53.0 degrees of the angle inclined below the horizontal, and the coefficient of kinetic friction 0.40 are used in order to find the work done by friction, work done by gravity, and work done by normal force. Work done by normal force is 0, as the equivalent of cosine 90 degrees is 0. Work done by friction is solved by multiplying negative coefficient of the kinetic friction, which is negative 0.40, to mass 12.0 times gravity 9.8 times cosine 53.0 times 2, which results in negative 56.62 joules. And work done by gravity is mass 12.0 times gravity 9.8 times sine 53.0 times 2, which results to 187.84 joules. With the formula of the network, all the values are added. Work done by friction, negative 56.62, plus work done by gravity, 187.84, plus work done by normal force, 0. This equals to the net work done on the package, which is 131.22 joules.
In the second problem, what's asked of us is to calculate the work done by gravity on a watermelon during a displacement from a roof to the ground. For us to solve this problem, we must locate what is given. 4.80 kilograms, 18.0 meters, and since we are on Earth, the gravitational pull should be 9.8 meters per second squared. We are looking for work, which has the formula of Fd. But first, we must find force, which has the formula of mass multiplied by acceleration. Therefore, 4.80 kilograms multiplied by 9.8 meters per second squared would equate to 47.04 newtons. We can now proceed in finding work. 47.04 newtons multiplied by 18.0 meters would equate to 846.7 joules. And this is our final answer.
For the third problem, we have a spring of negligible mass has a force constant K is equals 800 newtons per meter. How far must the spring be compressed for 1.20 J of potential energy to be stored in it? You need to be familiar with the formula in order to adjust this problem. You should be aware that the U essentially represents the spring's potential energy. The energy in the spring is going to be equal to 1/2 kx squared, where the x is the amount or distance that the spring is compressed and k is the spring constant which the problem did give us. Consequently, in this instance, x simply refers to the spring's compression distance, so we will be looking for the x. Once again, in other words, we are attempting to solve for the x variable since they are asking us to determine how much the spring should be compressed. So by entering several numbers, we'll be able to find the answer. So for our given, we have U is equivalent to 1.20 J and K is equal to 800 newtons per meter. We will now substitute our given to U and K, yielding 1.20, which is equal to 1/2 times K, or 800 times x squared. To get rid of 1/2, multiply both sides by 2. 2 times 1.20 equals 2.4, and 2.4 equals 800 times x squared. And because we are looking for x, we divide both sides by 800, which allows us to eliminate 800. As a result, x squared equals 2.4 times 800. And of course, we square root both sides to eliminate the x squared, or the x of the square. As a result, we have 2.4 multiplied by 800. Then our answer will be 0.0547. For our final answer, we will round it out or round it off. So our final answer is 0.055 meters.
As for the problem number 4, which talks about a 1.50 kilogram snowball that is fired from a cliff of 12.5-meter high and the snowball's initial velocity of 14.0 meter per second directed to 41.0 degrees above the horizontal. Using the conservation of mechanical energy, calculate the speed of the snowball as it reaches the ground below the cliff. The formula for this problem will be k sub 1 plus u grab sub 1 is equal to k sub 2 plus u grab sub 2. The formula will be 1 half mv sub 1 and 2 plus mgy plus 1 equals 1 half mv sub 2 and 2. The issue that we are asking about the speed of the snowball as it reaches the ground below the cliff. So we will find v sub 2. To find v sub 2, we must obtain the square root, which we will do by multiplying both sides by 2 and then dividing by m to isolate u sub grab 2. We need to get the square root first. For us to find the v sub 2, we also need to multiply both sides by 2, then divide by m to isolate the u sub graph 2. Explaining the solution. V of 2 is equals to square root of v of 1 squared plus twice of g times y sub 1. And v of 2 is equal to square root of 14 meter per second squared plus twice of 9.8 meter per second 2 times 12.5. Then v of 2 is equals to 12 meter per second squared. So the speed of the snowball as it reaches the ground below the cliff is 21.00 meter per second.
For the last problem, an 80.0 kilogram skydiver jumps out of a balloon at an altitude of 1,000 meters and opens the parachute at an altitude of 200 meters. A. Assuming the total retarding force on the diver is constant at 50.0 Newton with the parachute closed and constant at 3,600 Newton with the parachute open, find the skydiver's speed when he lands on the ground. B. Do you think the skydiver will be injured? Explain. C. At what height should the parachute be open so that the final speed of the skydiver when he hits the ground is 5.0 meters per second?
Here are the given. Y sub 1 is equals to 1000 meters. Y sub 2 is equals to 0. Change in x sub 1 is 800 meters. Change in x sub 2 is 200 meters. F sub 1 is equals to 50 newtons. F sub 2 is equals to 3,600 newtons. V sub 1 is 0 and V sub 2 is 0 as well.
For A, we will find the skydiver's speed when he lands on the ground. Since K1 and U grav is 0, U grav 1 plus W is equal to K2. Substitute, we will use the formula mgy1 plus F1 delta x1 plus F2 delta x2 equals to 1 half mv squared. Multiply both sides by 2 over m, then square root the equation to eliminate the square root in V2. With this, we have the square root of 2 mgy1 plus F1 delta x1 plus F2 delta x2 over m. Substitute, we have V2 is equals to the square root of 2 times 80.0 times 9.8 times 1000 plus negative 50 times 800 plus negative 3,600 times 200 over 80.0. The result is 24.49 meters per second, which is the skydiver's speed when he lands on the ground.
A parachute has a forward velocity of 15 miles per hour or 7 meters per second. Due to that, the descent of the skyjumper will be slowed. In conclusion, 24.49 meters per second is a dangerous speed for a skydiver to have when in air.
The formula used is D2 is equals to mghi minus 1 half mus squared minus h sub 1 f sub 1 divided by f sub 2 minus f sub 1. Now we will substitute the following. Hence, we have 80 times 9.8 times 1000 minus 1 half times 80 multiplied by 5 squared minus 1000 times 50 all over 3600 minus 50. Simplifying, we will have D2 is equals to 784,000 minus 1,000 minus 50,000 over 3,550. And our final answer is 206.5 meter.
Balaod, Benamira, Rodillas, and Suan.
We hope you enjoyed and understood.